7.A, area between curves. So back when we did like chapter 2 and 3, what was a derivative? So a tangent line. Then we went to chapter 4 and we started doing integrals. And what was an integral? Area under a curve. Now we're going to be doing area between two curves. All right. Oh my gosh. All right. No, it's just one. It's just one. So if we have two functions going on, all right, if I have an f function here, a g function here, an f function here, a g function here, an f function, g function, it doesn't matter what quadrant we're in. If we're above or below the x-axis, now that totally mattered when we just did area under a curve, right? If it was below the x-axis, it was always what? Negative, right? But for an area between two curves, it's always top minus bottom. So we're going to take an integral of top minus bottom. I would write that. That is extremely important. No matter if it's above or below the x-axis, it's always the top curve minus the bottom curve. We end up having the integral of a to b of our top function minus our bottom function. All right, let's do it. Here we go. So we're going to find the area of the region bounded by these graphs. Let's write them out. Y equals x squared plus 2. Y equals negative x. X equals 0. And x equals 1. Now, a lot of the times I would suggest writing out what they are or sketching the graphs of what they are. So let's start with the first one. X squared plus 2. What kind of graph is that? It's a quadratic. It's a parabola, right? And where does it start? It starts at y equals 2, right? And so we have a parabola going on like that. It doesn't have to be perfect. There we go. That's a great sketch. All right. Now let's look at this y equals negative x. Well, what's that kind of graph going on? Diagonal line. Which way is it going? Up or down? Down. It's going downward. All right. So it's doing something like that. Pretty good? All right. And then x equals 0 is another name for what axis? The y-axis. And then we have x equals 1. And so we end up having a vertical line going like that. So the area between these two is right there. Does that make sense? All right. So my integral is what it's bounded by. What's it bounded by? From 0 to 1. Well, what's my top function? X squared plus 2 minus, what's my bottom function? Negative x with respect to x. Now, this one's just a monomial, but I would highly suggest you distribute your negative. So I have minus a negative x, so now I have plus x. Now, because I want it in descending powers, I'm just going to do this. So now I have an integral from 0 to 1 of x squared plus x plus 2 with respect to x. All right, so now we're just going to do the first fundamental theorem. So what's my antiderivative? X cubed over 3 plus 2x from 0 to 1. All right. So now we're going to substitute in 1. So what do we get? 1/3 plus 1/2 plus 2. And then minus, we substitute in 0 and we get 0. Now, if this is a free response question, you could totally leave it like that. All right. However, I want to keep going just to make sure if it's a multiple choice question, we can get there. All right. So what do we convert it to? Everything sixth. All right. So now we have 2/6 plus 3/6 plus 12/6. And how many sixths do we have? 17/6. So the area bounded by those curves is 17/6. All right, pretty good? All right, let's do another one. So now I want to find the area of the region bounded by 2 minus x squared and x. All right, so let's sketch out what it looks like. What does this 2 minus x squared look like? It's an upside down parabola. All right, so it goes up 2 and then it goes upside down, kind of like so. All right, and then what does this x look like? Just a straight line going through the origin, right? So something like that. Well, which one's on top? F is on top. Which one's on the bottom? G in this case. All right, that's good. However, when I take an integral, I need to know what my lower limit and my upper limit are. Do I know those? I don't. So what do I need to solve for? My intersections. Well, how do we solve for intersections? We set them equal. So let's do it. So now I have 2 minus x squared is equal to x. I need to figure out where these things are intersecting. All right. Now, I personally would like x squared to be positive, so I'm moving everything to the right. You good? So now I have 0 is equal to x squared plus x, and then minus 2. All right, we got a quadratic. What do we do with those things?
F them up.
F them up. So now we end up having x what? Plus 2 and x minus 1. So using the zero product property, I end up getting x equals negative 2 and 1. All right. So that solved for my intercepts. Those solved for my bounds. So now I have the integral from what to what? Negative 2 to 1. Who's on my top? 2 minus x squared minus, who's on the bottom? X. All right, so I'm going to distribute the negative before I do anything. So now I have 2 minus x squared minus x dx. I'm just going to leave it like that because why not? All right, so what's my antiderivative of 2? 2x minus, what's my antiderivative of x squared? Minus
1/3 x cubed.
X squared over 2, right? All right. From negative 2 to 1. All right. So now let's substitute in 1. So what do we get? 2 minus 1/3 minus 1/2. Minus, now we substitute in negative 2. So what do we get? Negative 4. And then negative 2 cubed is what? Negative 8. However, it's a negative, so now we end up with a positive 8/3. And then I substitute in negative 2, and I end up with minus 2. All right. All right, what would I highly suggest you do right here? Distribute the negative. So we go pew, 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 pew. Right. You did a great job. You did a great job. All right. I know, I don't say that often. All right, so now we just need to combine like terms. Well, I see something here that I kind of want to work with. You see this negative 1/3 and this negative 8/3? I personally see that, and I'm going to kind of jump to there. So what does negative 1/3 and negative 8/3 combine to? Negative 3. All right. And so then I have this 2 and this 4 and this 2 going on. So that becomes what? 8. So I have 8 minus 3. And then what's still left over?
Minus 1/2.
Minus 1/2. All right. So I have 8 minus 3, which is what? 5. 5 minus 1/2 is? 9/2. So the area between those two curves is 9/2 units squared. All right. Pretty good? All right. Keep moving. So I'm going to help you set this up, and then I'm going to let you go. So we're going to find the area of the region enclosed by the parabolas y equals x squared and y equals 2x minus x squared. Again, let's start out with sketching a graph to see what's going on. If I have to graph y equals x squared, what is that? True. It's a parabola, right? All right, so it's just a parabola going up. All right. And then this 2x minus x squared. What is that?
Another parabola.
It's a parabola. Which way is this one going? Down, right? And so I have students that get bothered by where you draw it. Does it make sense to draw it down here? No, because will it enclose anything there? No, so it can't be down there, but it's got to be up here, all right? And I have students that are like, it doesn't intersect there. Do we really care? Not really. What are we worried about right here? Which one's on top and which one's on the bottom? It could be right here. It is. However, it could be right here. It's not. But do we care? No, truly we care about what right now? Which one's on top, which one's on the bottom? Because you're going to algebraically find out where they do what? They intersect. All right, and that will tell you more information. Okay? All right, don't be worried about your sketch too much. So the first thing we need to do is solve for what? The intersections. All right, so how do we show that we're finding intersections? We do what? We set them equal. And then once we solve, we get x equals 0 and x equals 1, yes? So those are our bounds. Those are our limits. So then we have the top minus the bottom. I combined, and so then we take our antiderivatives. So we get x squared minus 2/3 x cubed from 0 to 1. And then we substitute 1, we substitute in 0. We end up with 1/3. Good, good? All right. Let's bust out our calculator now. So now we're going to find the area of the region enclosed by these two functions. We have x divided by the square root of x squared plus 1. I truly do want you to write these out in your notes too. All right. And then we have y equals x to the 4th minus x. Now, do we know what these necessarily look like? Not too much. All right. And these aren't going to play nice either. So what do? We graph them in our calculator. So let's do it. So we have them graphed. Hopefully it looks something like that. Now, what do we know from this right now?
Probably intersect at 0.
Oh, okay, great. But what's on top?
The red.
The x over the square root one. All right, and then what's on the bottom?
The blue. Black.
The black one in this case, the x to the 4th. All right, so that's what we know so far. So we do know the top and the bottom, so we can do our integrand. However, what do we need to solve for? Our intersections. Now, what do we need to show to solve for intersections? We set them equal. Now, I know you're going to do this in your calculator. However, I am going to require you to show that you're setting them equal right here. Why would I do that? Because AP graders need that. Is everybody hearing me?
Yes.
If you don't show that and you magically get the intersections, am I going to give you full credit? No. Okay? Because I'm so mean. All right. That's how you're going to be graded. All right. So now let's find our intersections. So let's go to second calculate. Intersect. Get close to them. Triple press enter. And what do we get? We get x equals 0 and what? 1.1807757. All right, so we get x equals 0 right here. X equals 1.1807757 right there. Why did I not round to 4? Because guess what's going to happen after I do it again? We're going to round again. So let's keep everything right here. Is everybody hearing me? Okay. All right. So now I'm ready to set up my integral. So my integral is going to go from what to what? 0 to 1.1807757. And then who's my top? X over square root x squared plus 1 minus the bottom of the quantity x to the 4th minus x dx. Guess what happens to some students? They don't do the quantity, which means this portion's going to be wrong. All right? So now let's bust out our math what? Math 9 it. All right, so we put it in our calculator. However, now what are we actually allowed to round to? 4 decimals. Okay. There we go. Who wins the race? Who wins the race? Gunnar definitely didn't win last chapter.
Yeah.
I think he does.
Who wins the
Did
race?
Evan get 100?
The tortoise, the turtle wins the race.
Okay, but with the